Hello everybody, we're getting ready to do lesson 3 of SAT Math Level 2 preparation today. And today's lesson, you got 8 points here of notebook taking. Have your notebook guides out for quadratic functions. We cover this, definitions, parabolas, completing a square, quadratic formula, and the discriminant. And then we have 10 points here on your classwork sheet. Have those out in front of you. Students, put your name, date, period in my class, due date for onliners and homeschoolers. And let's go into page 1 here into your notebook entry. Quadratic functions are polynomials in which the largest exponent is n equals 2. The standard equation of a quadratic function is p of x equals ax squared plus bx plus c, and its graph is called a parabola. If a is greater than 0, the parabola opens up, and the lowest point on the parabola is called the vertex. If a is less than 0, the parabola opens down, and the vertex is the highest point on the parabola. The x coordinate of the vertex is given by the formula h equals the negative of b over 2a. Substitute h for x in the equation of the parabola to get k equals 4ac minus b squared over 4a. The y-coordinate of the vertex, so this is your y-coordinate of the vertex. The axis of symmetry of a parabola has the equation x equals h. The graph of each side of this axis is the reflection of the other side. The equation y equals a times quantity x minus h squared plus k is called the vertex form, and it's equivalent, and is equivalent to y equals ax squared plus bx plus c. The domain of a quadratic function is all real numbers unless otherwise specified. If a is greater than 0, the y-coordinate of the vertex is the minimum value of the quadratic function. So we have a min when a is greater than 0. So the range consists of all y values greater than or equal to that coordinate. If a is less than 0, the y-coordinate of the vertex is the maximum value of the quadratic function. So the range consists of all y values less than or equal to that coordinate. The following examples demonstrate how to analyze the graph of a parabola. Okay, so going into our first example here, number, A, analyze the graph of y equals negative x squared plus 4x plus 5, and here it is here. So first observe that a equals 1. Well, actually, it's a negative 1 would be right here. B equals 4, and then C equals 5 over here. And then since a is less than 0, we have a negative 1 here. The parabola opens down, which it does. It opens down. And the vertex is a maximum. Here's your vertex up here. It is a max. And then since h equals a negative of 4 over negative 2, which is positive 2. Here's your h right here. And then k is the negative of 2 squared plus 4 squared plus 5 equals 9, which is up here. Here is your k. The vertex is 2, 9. So here's your vertex up here, 2, 9. And then the maximum is 9, here's your max, and then the range is negative infinity, so it goes down here to negative infinity, and 9 up here, it's in that interval between 9 and negative infinity. The axis of symmetry is x equals 2, here's your axis of symmetry, x equals 2, and the graph crosses the x-axis twice here at negative 1 and at 5. So there's your solutions for that parabola. These are the two zeros of the function, and these are also the solutions to the equation. Negative x squared plus 4x plus 5 equals 0. The figure below shows the graph of this here. This is your figure below up here. So that is the graph of this function. Let's try another one. Analyze the graph of y equals 3x squared plus 2x plus 5. So first observe that a equals 3, b equals 2, and then c equals 5. Since a is greater than 0, the graph opens up, and the vertex is a minimum. Since h equals the negative of 2 over 6, which equals negative 1/3, and k equals 3 times negative 1 over 3 square plus 2 times negative 1 over 3 plus 5b, 14 over 3. So here's your vertex here, be a negative 1/3 and 14 over 3. The min will be a 14 over 3, and the range is 14 over 3, positive infinity. So it goes up. The axis of symmetry is x equals negative 1 over 3. The figure shows the graph here is finally your graph here of this parabola. How it goes up there. Here's your vertex. Your vertex is negative 1/3, 14/3 right there. The graph does not cross the x-axis. This means that the solutions to this equation are imaginary. So we have imaginaries as our solutions for this. As seen in example A, one method of solving certain quadratic equations is to transform the equation so that one side is equal to 0, factor the other side, use the zero product property to equate each linear factor to 0, and then solve each linear equation. So a tip in doing this, the sum of the zeros is negative b over a, and the product of the zeros is c over a. So here's kind of like a shortcut here if you don't want to do it the traditional way, but I think as long as you have a calculator, you really, during the task, you can just use your calculator to graph it and find out where the vertex is, and also where the solution is. Okay, so moving on to our next example here. C, solve x squared minus x minus 12 equals 0. So factor the left side, so we need to factor the left side, and we get this, x minus 4, x plus 3 equals 0. Set each factor equal to 0, and solve each linear equation. So we have x minus 4 equals 0, x plus 3 equals 0. When x equals 4, when x equals negative 3, that would be your solution. And then for D here, solve x minus 6 quantity squared equals 0. So when we have that, in this case, x equals 6 twice, so x equals 6 is said to have a multiplicity of 2. Will be another way of approaching that. The quadratic formula, x equals the negative of b plus or minus square root of b squared minus 4ac over 2a, can be used to obtain the exact solutions of any quadratic equation in the form of ax squared plus bx plus c equals 0. This formula is the result of completing the square for the general quadratic. The expression b squared minus 4ac under the radical in a quadratic formula is called the discriminant. Here's your discriminant here. If the discriminant is positive, there are 2 real roots. If the discriminant is 0, there is 1 root, a multiplicity of 2. If the discriminant is negative, there is a conjugate pair of imaginary roots. Note also that the 2 solutions given in the quadratic formula are conjugates u plus v and u minus v, where u equals the negative of b over 2a, and v equals radical b squared minus 4ac over 2a. This implies that the sum of the roots of a quadratic equation is 2u equals 2 times the negative b over 2a, which equals the negative b over a, while the product of the roots is u squared minus v squared equals b squared minus 4a squared minus b squared minus 4ac over 4a squared, which equals 4ac over 4a squared equals c over a. So it's just another way of looking at the quadratic. I mean, if you're going to have this much time really during your test, which I don't think you will, you just revert back to using your calculator. On the level 2 test, you can use a calculator through the whole test, not like level 1. So I would just use your calculator. I mean, this is cool, but how's that really going to help me do the test quicker? I don't know. It's going to let you understand certain relations amongst the quadratic equation and the quadratic formula is all it does. Okay, moving on to our next example, E. Solve 2x squared minus 8x plus 6 equals 0 by completing the square. So first divide both sides of the equation by 2. We need to get this down to 1 here to make the coefficient of x squared equal to 1. X squared minus 4x plus 3 equals 0. Next, isolate the constant term by subtracting 3 from both sides of the equation. So we have x squared minus 4x equals negative 3. And add the square of half the linear coefficient negative 4 to both sides. So then we have x squared minus 4x plus 4 equals 1. The left side of the equation is now a perfect square. X minus 2 squared equals 1. Taking the positive and negative square roots, we get x minus 2 equals 1, or x minus 2 equals negative 1. Therefore, x equals 3, or x equals 1. That is one way of completing a square. F. Use the quadratic formula to solve 3x squared minus 4x plus 1 equals 0. So a equals 3, b equals negative 4, and c equals 1. Substitute these into the quadratic formula, and this is what we have here. We crank that out. We end up with 1 or 1/3 as our roots for this quadratic. G. What is the product of the roots of 3x squared equals 6x plus 4? Transform so that one side of the equation is 0. So 3x squared minus 6x minus 4 equals 0. Once we do that, then with the product of the roots is c over a. So here is our c, and then here is our a. So we have negative 4 over 3. So the product of your roots be a negative 4 over 3. And that is your lesson on quadratics. That is section 3, part 1. SAT Math Level 2 preparation. Animated PowerPoint Math Video at AOL.com for questions or course materials. Thank you very much.